is up, math superstars? In this edition of Mr. Peterson Presents, we're going to be talking about similar figures. So similar figures, these are polygons, so any-sided shape, and these polygons, they have the same shape, but not the same size. And so if two polygons are similar, their corresponding sides are proportional. And so we're given this example here. So we have triangles, so the way we mark out triangle, so a triangle ABC is similar, so the similar is, the sign for that is that squiggly mark, is similar to triangle XYZ. So we know that these are proportional, and we're going to set up proportions to figure out the corresponding sides. So in this, so we can say that side AB, which is the first two letters right there when we look at our example, we say that corresponds to side XY. And so we can know this one of two ways. We can look at this example right here for this information, or we can take a look at the picture. So if the picture isn't really labeled, I like to go off of the example. That way I will always get it right. So we say that the first two letters, AB, those correspond to the first two letters of the second triangle XY. And then we can take a look at BC. So BC, or the second and third letters, match up with side YZ. And side CA, C to A, that third to first, matches up with the third to first, which would be Z to X. And so that in doing this, we can actually set up a proportion that will help us to be able to solve if we need to find a missing side length. And so we can see that our first triangle is in the numerator, and our second triangle is in the denominator. So the corresponding side AB would be over XY. And so for our second one, corresponding sides BC would be over YZ. And last but not least, here we have CA, or AC, would be over XZ. And so this proportion right here that we set up is going to give us some useful information in figuring out side lengths. So now we're given this challenge here. So we're going to write a proportion to show the corresponding sides here. And so here we have to write out what the triangle is first, and then we can write out our corresponding sides. So we can do triangle. We'll list this ABC is similar, so we have that similar sign. And remember, angle A has to match up with the angle in our second triangle. So the order of these does matter. And so we can see that angle A right here in the corner has one arc. That will correspond with angle D with our one arc there. So we say that this corresponds to triangle D. And then we have, for B has two arcs, E has two arcs. So we can put E. And then we can do three arcs for C and three arcs for F. So we have triangle ABC is similar to triangle DEF. So now let's go ahead and set up our proportions. So we can say that side AB, that's proportional to side DE. And then let's also set up our second side length of BC, that's proportional to EF. And our last proportion is AC is proportional to DF. And so all we did was we wrote a proportion for the corresponding sides to these two similar triangles. And of course we can use similar figures to find the measure of the missing sides of objects. So we're given some information here in example number 2. We're given our triangle right here with the order that matters. We have triangle ABE is similar to triangle DCE. And we got to solve for the value of x. So first thing is, let's go ahead and write our proportion. So we have on our numerators, so we have AB, and then we have BE, and then we have AE. So now let's take care of our second triangle. So the first and the second letter is DC. Our second and our third is CE. And our first and our third are DE. So we set up our proportions. And now we're going to replace some values here. So we need to figure out what X is for line BE. And so in doing this, we're just going to use, let's just use this part of the proportion right here. So we can replace AB with 7. DC is going to be 4.2. We're just replacing the side lengths for what we know. Would be equal to BE would be X, and CE would be 3. So now what we can do is write out our equation. So we can cross multiply. So we have 4.2x would be equal to 21. And what we could do now, let's go ahead and divide both sides by 4.2. So in doing so, of course, you can use your handy-dandy calculator. 21 divided by 4.2 will give us the value of X would be 5. And so we can say that side length BE would be 5. And we're given a label right here, so this would be 5 feet. So X would be 5 feet. And so here, just to recap, we can set up our proportion for these similar polygons, being triangles. We replace the values except the one we didn't know, which was BE. We cross multiply just like we do in solving proportions to simplify to find for that missing side length.